Mr. Aaron, Mr. Ryan.
Hello. We're not a teacher.
Hello.
Hello.
So today we're going to talk about a square root. Do you still remember square
Yeah,
root?
it's easy. The square root of 64 is 8. The square root of 100 is 10.
Well done. So this
Square
square root.
root of 196 is 14.
Okay,
The
well
square
done.
root of 144.
Alright, enough. You got the idea. So this square root is also, you can also write it as half. Yeah? Yeah, to the power of half. Yeah, it's the same thing. Yeah, or sometimes you can do it 0.5. So it's the same thing. Yeah, do you get it?
Yes.
Yeah. So now we are going to write a function to calculate the value. Yeah. For example, why are we doing this? Look, this is, what's this?
Triangle.
And if I tell you this is 90 degrees, this is the right triangle, right? With the right angle triangle. How about if I tell you this is 3, this is 4, and what's the length of this side? Do you still remember the formula?
I know. 7. No, 6.
No. Look,
7.
no. If this is right angle, okay? And if this is A, this is B, and this is C, so it must satisfy that A squared.
5.
Well done. A squared plus B squared equals C squared. Is it easy?
What does that mean?
Look, this is 3, this is 4. So 3 squared plus 4 squared equals 5 squared. This is 9 plus 16 equals 25. Got it? If this is a triangle and this is right angle, it must satisfy that. Do you get it? Yeah? Do you understand how we got it? No?
Yeah.
Okay.
How we get it.
Yeah, we can prove it different way. We can tell. I can show it to you next lesson. Okay, how we get this formula. But this is not the point of today.
Ow.
What I want to do is that if this is 1,
If
this is
2,
1, this is 1,
This is 2.
and what's the length of this side? It's 1 square plus 1 square equals this side. Yeah, this side c square. So that's 2 square equals c square.
Yes.
No. Two equals c square, right? Yes.
Yeah.
So c equals square root of 2, right?
Why C square equal to y?
I just told you a square plus b square equals c square. Remember? This is a, this is b, this is c, this is right angle. You must satisfy that. Do you get it?
Oh.
Yes?
Why isn't letters now?
What do you mean? Because if I tell you that this is 1 and this is 1,
And this is 1 and this is 1.
and then what's this side?
It's gonna be
Square root of 2. What?
square root of 2.
Yeah.
What's the square root of 2?
It's a number between 1 and 2, right? And then how about we calculate this value? What is it? It must be between 1 and 2, right? Yes? Because 1 square is 1, right? 2 square is 4, right? Yes?
Yeah.
If we square it, it's 2. So how about it? And precisely it's between 1 and 1.5. Because 1.5 square equals what? 15 square equals what?
225.
And 1.5 is 2.5, right? Yeah, 1.5 square equals 2.5. Look, c square equals 2, okay? And I say 1.5 square equals 225. 1 square equals 1. So c is a value between 1 and 1.5. Am I right? Yes? Because it's in the middle. So that's very interesting because we know this function, square root, y equals square root x, is monotone. Remember the word? Monotone. Monotone, increasing. It means the bigger of x and the bigger of y, right?
Yeah.
If x is increasing, y is also increasing, right?
Mm.
Am I right?
Yeah.
So if we plot this function, Ryan, this is going to be interesting.
Ryan.
This is x, this is y.
This is y. And
One
this
x is
z.
0. One x is 0, y is what?
1 x is 0, y is 0.
Yeah, well done.
Hooray! 3.
When x is y is what?
What did you say?
When x is 1. 1.
1.
Yes, 1 square of 1 is 1, yeah? So this here.
Yeah.
When x is 4.
15.
No, x is 4. 4 square root. Square root of, yeah, we're done 2. So this is 1. This is 2, 3, 4. 4 here, and then there will be 2, right? 2 here, yeah? 2 here, okay? So when x is 9,
X is 9 and it's 3.
Yeah, 3. So 9.
3.
5, 6, 7, 8, 9. So 9. 3 is approximately here, yeah? It's approximately here, so it will be approximately here. So if you plot this line, it will be something like that, right? Something like that, okay?
It looks a bit weird.
Yeah. Actually, it's a curve. I didn't draw it properly, so it's a curve. Okay, it's a curve like a monitor increasing curve. Yeah.
I forgot now.
Okay. Then, yeah. I'm very bad at drawing, but you get the meaning. Yeah. So when x is increasing, the y is also increasing. Yeah. Okay. So now look, where is 2? When x is 2, here. Yeah.
Yeah.
X is 2 here. And this is 2. This is 2. Yeah. When x is 4, this is 2. So here is between 1 and 2, right? Yeah. So this square root of 2 here is somewhere here, right? Yeah, we don't know, yeah? So we can how can we calculate this value? Interesting. I give you a hint. Binary search. Yeah. Look, if this monitor increasing, let's guess a value, right? If let's guess a value like the left bound is 0, right? It can't be smaller than 0, right?
Yeah.
And the right bound, if it's more than 1, we say it's x. Now we find it in the middle, and then we do this s square to check if it's bigger than the value.
1 point.
Yeah. Do you still get it?
1 point.
1 point something. Yeah.
1 point.
And then if it's smaller, then we cut it into half. Remember?
1.75.
Okay. So no.
Huh.
I show you the value later. Okay. If you're interested. Okay. Let's do this. Define binary square root.
Definitely close.
X. Okay. Yeah.
Column.
Okay. So if x is smaller than 0, we return none because there's no such value, right? Because you can't find any real number. Okay. Can you not block it? Let me check it. Yeah. You cannot find any negative. You cannot find any real number that square equals negative. Am I right?
Yeah.
What I'm talking about is real number. Okay. You will learn other numbers other than real numbers, imaginary numbers later. But the numbers we use daily, like 1, 2, 3, 2.5, yeah? Yeah? Square root of 2 are real numbers. Okay? These are the numbers, yeah, we know. Okay, so look, if x is smaller than 0, we return none. Okay?
Yeah.
Yeah, that makes sense, okay? Now, if x is smaller than 1, left, right, if it's smaller than 1, left and right, left is 0 always. The right bound, we set it to 1, right? Because if it's x is smaller than 1, square root of x is also smaller than 1, yeah? Yeah, so we set it to 1, okay? Otherwise, if x is bigger than 1, the left is 0, right, we set it to x, because when x is bigger than 1, when x is bigger than 1, square root of x is smaller than x, right? When x is bigger than 1, okay? Got it?
Got it.
Yeah.
Yeah.
So now we set it up, then we have this,
Don't want them.
now we need to have this middle value. Now we set it to current value. Let's say we current value and middle value.
And
Let's all set it to 0 because middle value is the initial value, yeah? then we can have
Need 0.
it's 0. At the beginning, we guess. This mid number is the number we guess. Okay, we guess it's the square root of anything is 0. But this guess is not right, right?
Yeah.
Don't worry, we make a guess. The result is the current is the mid times mid to the power of 2, mid times multiplied by mid. So now y ABS. Do you still remember ABS? Absolute value, right?
Yeah.
Absolute value. If this current value CUR minus x, yeah, is still bigger than the error. Error we set it to 1e minus 5, so it's 0.0001. It's a very small difference, right? When it's bigger than that, then we do this mid equals left plus right.
Equals.
Then what? Middle. How do you get the middle from left and right? Left plus right, what? Divided by
2.
2. Yeah, that's the middle. We get the middle, right?
Which is middle.
And current would be mid times mid. Yeah, this is the main value we get. If current is bigger than the x,
Then
right?
what?
So if this is bigger than x, so it means that it's in the lower half, right? Because the guess value is bigger than the guess value. Guess value is mid. Mid times mid is bigger than x. It means that we guess a value which is larger, right? So now then we can search in the lower half, which we need to say right equals mid, right? As what?
Column?
No, as a column, yeah. What? If it's smaller than x, what does it mean?
It's on the.
Opposite side.
Yeah.
So we say the left equals what? Mid, right?
Yeah.
Because look, left and right. Left, right. And then that's mid, yeah? If current is bigger than x, then it means that the value is not in the upper bound, it's in the lower bound. So we said right equals mid, yeah? If it's in the upper bound, then we said left equals mid, right? So every time we cut into half, right? Yes? And after this, what should we do? Return what? Return what? Return mid or current?
Current. Mid.
Mid. Return mid. Because mid is the value of the square root. Current is the square root times square root, right? It's the value, the result we are comparing to x, right? Okay? Do the coding time.
Coding.
Coding.
Ooh.
Oh, too tough.
Hey.
Oh, sorry.
Hey. Gotcha.
Jay.
Bet you can't catch me. Ooh.
Too close, please. Can you sit down, please? Sorry. Okay, so let's do the coding. Interesting coding part. Is it very clear? Yeah, I think it's very clear. Hi. 1, 2, 3, 4. It's still very clear, yeah? Okay, good.
Yeah.
Let's do the coding. Yeah, it's very good. Okay, let's do this. Look, what?
Buy me a cup.
Square root.
Buy me a cup of coffee.
Yeah, sit down. Okay, let's define square root, yeah? Square root, x. Do you still remember? If x is smaller than 0,
Then what?
return what? None.
Yes.
If x is smaller than 1, left, right equals 0, 1, right? Because if it's smaller than 1, its upper bound should be 1, right? As left, right equals what? 0, what? X, right?
Yeah.
Then current mid equals 0, 0.
Yes.
Y ABS. Let's add a parameter error. Okay, error. Let's call it error. Small error, which is we allow the error like by default be 5. Okay. If current minus x is still bigger than error. Error. Okay.
Error.
divided by what?
2.
Okay, then current equals mid what? Times mid, right? You can also do this. Mid. This is also power to the power of 2, okay? It's the same thing. If current is bigger than x, so what should we change? Right equals what?
Left.
Mid.
Oh.
Else what? Left equals what?
Mid.
And return what?
Mid.
Yeah. Let's do this for I in range 10. Okay, let's do this. Then print square root of I is square root of I. Okay? Let's print it. Let's see if it works. Okay? Python sqrt.py. Does it make sense? Can you check if the values are alright?
The square root of 0
Is 0, yes.
square root of 1 is
Yeah,
0.
because computer have these look the 5 1 2 3 4 5, yeah. If we change this arrow, okay, if we change the arrow by default to 8, and you can see what's the difference, okay. Okay, so you see they're more nice, yeah, they're more nice, right?
Yeah.
So this is because computer calculated and using this floating point, there's always a small mistake, but this value is very close to 1. And look, square root of 2, yeah, the value you want to know is 1.41, yeah? Alright?
1.41.
For we can calculate and look at 7. And let's try the number between 1 and 0, okay? Let's verify, okay? Print. You want to know that the 1.41, yeah? Times 1.41, 4. I think it's 1.414. Let's just times it twice. So you can do this square. Yeah? Print sqrt, let's say 0.5. Okay?
Yeah.
And print sqrt 0.01. Okay, let's see if what does it come to. Look, yes? You see? Its value is very close to 2, so it means that the value, because what we just do is 1.414 times itself is equals to 1.999, so it's very close to 2, right? So the square root of 2 is that, it means it's correct. 0.70, this is the square root of 0.01. Yes. Square root of 0.01, yes, because 0.1 times 0.1 is 0.001, okay?
Yeah.
So this is correct, yeah? So let's check if this, no, not this one. So let's go through this again. Square root with this arrow, and smaller than 1, we set the range from, basically this left and right is define the range we are searching the value. So we define the range between 0 and 1. We search the value between 0 and 1. And this left, if x is bigger than 1, we search the value between 0 and x. Do you get it? Yeah?
Yeah.
If it's x is bigger than 1, actually we can search the value between 1 and x, right? Am I right? Yeah. So actually you can change this range because it can't be less than 1, right? Am I right? So if you run it again, it still finds the value, right? You see? Yeah? Yeah? You still get it. So, and then when this arrow current value is bigger than and x is bigger than the difference, then we find the middle, and then we calculate the value. And if the current value is bigger than x, then we know it's not in the upper bound. We search in the first half, right? Otherwise, we search in the second half. Do you get it? Yes? So you will always repeat until you find the value very close. This ABS current minus x, this is calculating the difference between these two values, current and x, right? And then if it's bigger than the arrow, then we always repeat until we find a value which is very close to x. when we find the current which is very close to x, what does it mean? It means that the middle value is the square root of x. Then we return the mid. Okay? Good job? Any questions?
No.
Okay, good job today. Good job. Good job, good job. Good job, good job.
Bye. Bye. Bye.
Bye bye.
Bye. Bye.
Bye bye.